This section will demonstrate the TechMove GLMS web API using Swagger. Swagger is an open API documentation and testing interface that is automatically generated from the API code. It allows developers and administrators to see all available endpoints, their expected inputs and outputs, and test them directly without needing a separate tool like Postman, which we learned about last year. The API is running at localhost 7105, and Swagger is configured to load at the root URL. Before I can test any protected endpoints, I need to authenticate. JWT stands for JSON Web Token. It is a way to prove identity without storing sessions on the server. Whenever the user logs in, the API generates a token that contains the user's information and role. Every request thereafter includes this token in the authentication header, and the API verifies it before allowing access. If the token is missing, the API returns 401 unauthorized. If the token is valid but the user doesn't have the required role, the API returns 403 forbidden. There are two roles in the system, admin and client. Each have access to different endpoints, which I will go through in this section. This endpoint is where we get the token from. The API verifies the credentials using ASP.NET Identity, generates a JWT token containing the admin's ID, email, and role. I'll call this endpoint, enter the admin email and password, click execute, and the token will be returned. I will copy this token and click the authorize button at the top of Swagger and paste this token in, and then click authorize. Now all my requests will automatically include this token. This endpoint returns all clients from the database and returns a 200 OK with a JSON array. This endpoint creates a new client record and returns 201 created. This endpoint gets clients by the ID. This endpoint updates all fields of the existing client. This removes a client by their client ID it is removed from the web app.
This endpoint gets all the contracts from the database. It returns 200 OK with a JSON array. I can also filter by start date, end date, and status using query parameters. This filtering is done on the server side using link on in contract servers. This endpoint creates a new contract. The contract ID is also generated. The API returns 201 created with the new contract, including its auto-generated ID. The new contract is visible on the web app. This endpoint gets a contract by its ID. Put replaces the entire contract object. It requires all fields to be provided. If any fields are missing, it is set to its default value and returns 204 no content on success. Changes can be seen on the web app. This endpoint deletes a contract by its ID. Patch only updates the status field of a contract. It only changes one specific field. When the status changes, the observer pattern is triggered in the backend. The contract service calls the service request observer, which automatically cancels all pending service requests on this contract if the status is set to expired or on hold. The status change is shown on the web app. This endpoint gets all contracts belonging to a specific client by their client ID. It returns 200 OK with the JSON array. This endpoint is a client only endpoint, which is restricted to the client role. When called with a client JWT token, it returns only the contracts belonging to that logged in client. The client ID is read from the JWT token, so the client can never access another client's contracts. When I call this as the admin, I get a 403 forbidden. Now I know when I log in as a client, her with the client token, this endpoint will return all of her contracts. Now I will sign in back in as the admin. This shows the currency rate gotten by the currency API, the currency conversion API from part 2. This endpoint converts a amount into using the currency exchange rate. This shows the admin dashboard. It's just a count of all the contracts and clients. This endpoint retrieves all service requests in the system. This is only for admins. It returns 200 OK with the JSON array. This endpoint retrieves all service requests belonging to a specific client by their client ID. It returns 200 OK with the filtered array. This endpoint retrieves a single service request by its ID, including the contract, client, and client details. It returns 200 OK with the found, if found, 404 not found if it does not exist. This updates all fields of the service request. The ZAR cost is automatically recalculated using the live exchange rate and returns 200 OK with the updated service request. The update can be seen on the web app. This deletes a service request. The deletion can be seen on the web app. This endpoint returns the current live USD to ZAR exchange rate. It returns 200 OK with the rate value. If the external exchange rate service is unavailable, the API falls back to the default rate of 16.69. This is the strategy pattern handling availability. This is the client only endpoint. It returns only the service request belonging to the logged in client. The client ID comes from the JWT token and returns 200 OK with the filtered array. You can see all of this. This client can see all of their service requests. This is where a client can create their own service request. This deletes. You can change the status, or you can change any field of the new created service request, the newly created service request. But remember that the client can't change their status, so the status here won't work. So it will still have to be. It will still have to be 0. And it won't change, but the. Oh, was it already plain? They change now. You can also delete a service request by the ID. Admin users have access to all endpoints except the My Client endpoints. Client users have access to the read endpoints such as Get API clients, plus all the My endpoints for their own data. Any client-only endpoints accessed by admin gets a 403 forbidden, and vice versa. This is enforced by the JWT token. The role claim is inside the token determines what the user can access. This section will go through the source code to show how the application implements the design patterns. The solution has 3 projects. The Web API project is the backend, where all business logic and database access is handled. The MDC project is the front-end presentation layer, and it has no direct access to the database. The test project contains all automated tests. This three-layer structure is the foundation of separation of concerns. Separation of concerns means that each layer has one responsibility. The API layer talks to the database and enforces business rules. The MVC layer handles what the user sees and calls the API for data. The test layer verifies everything works correctly. These layers are completely independent. Contracts controller. This controller has no database code and no database calls. It only calls methods on contract service. Contract service is the repository. It abstracts all database access behind a clean interface. The controller does not know how the data is stored. It just asks the service for what it needs. Observer pattern. After updating the status, it calls underscore iObserver on status change async. Service request observer. Service request observer. This implements iContract server observer. When the contract status changes to expired or on hold, the observer automatically finds all pending service requests on the contract and cancels them. It also sends an email to the client. The controller does not need to know any of this. This is the observer pattern. One event triggers multiple reactions without the event source needing to know about them. This implements iService Request Factory. When a service request is created, the factory first validates the contract exists and is active. If the contract is dropped, it throws an exception saying contracts must be active. If expired or on hold, it also throws. Only if the contract is active does it proceed to create the service request and calculate the ZAR cost. This centralizes all service request creation logic in one place. No matter where in the system a service request is created, it always goes through this factory. The currency conversion is a strategy. The system depends on the interface, not the concrete implementation. This fetches the live USD and ZAR rate from the external API. If that service is unavailable, it falls back to a default rate of 16.69. All services are registered here. They are all registered as scope, meaning a new instance is created per request. The controllers receive these dependencies through their constructors. This section shows how the MVC frontend has been completely disconnected from the database. Before this refactoring, the MVC controllers called application DB context directly. Now the MVC controllers have zero direct dependencies on the database. All data access goes through the web API over HTTP. The old architecture was MVC controller to application DB context to SQL server. The new architecture is MVC controller to IGLMS API servers to HTTP clients to web API to application DB context and then to SQL server. The MVC layer does not know anything about the database anymore. It only knows about the API. This GLMS API servers class is the concrete implementation of IGLMS API servers. Every single method uses HTTP client to make an HTTP request to the API. There is no database code anywhere in this class. If an API call fails, the methods return null or an empty list instead of crashing. This is the error handling for failed API calls. JWT and MVC app is in the authorize API async method in the admin dashboard controller. This is called at the start of every action that needs data. It calls login async with the admin credentials, gets a JWT token back, and calls set token, which sets the bearer token on the HTTP client authentication header. Every API call in that request automatically includes this token. In the admin dashboard controller, application DB context is commented out of the constructor because the MVC is no longer linked to the database. The only data dependencies is IGLMS API servers. The actions called methods from GLMS API servers. There is no SQL anywhere in this controller. In the client dashboard controller, it uses IGLMS API servers for all data, but it adds an extra security layer. Every action first gets the logged in client's client ID from the identity user records, then passes that into the API methods to filter results. All business logic has moved to the API layer where it belongs. This section demonstrates the automated integration tests. Integration tests call the actual running API endpoints and verify the complete flow from HTTP request through the API to the database and back. To run the test, the API must be running first. We have 27 tests covering authentication, contracts, service requests, currency, clients, and the client-specific endpoints. You can see all the API integration tests have passed. This authentication test verifies that valid admin credentials return 200 OK with a and a JWT token. This verifies that invalid credentials are correctly rejected with 401 unauthorized, proving the authentication system is working and not allowing anyone in, just anyone in. This contract tests verifies that get API contract returns 200 OK when authenticated. This one verifies that get API contract returns 401 when no token is provided. This proves that the JWT authorization is protecting the endpoints correctly. This verifies that get API contracts returns valid JSON array, proving that the API is returning data in the correct format. This verifies that the post API contracts creates new contracts return 201 created. This is the create operation within the CRUD demonstration. This verifies that get API contracts ID returns OK for a valid contract ID. This verifies that get API contracts ID returns 404 not found for a non-existent ID, proving that API handles missing resources correctly. This verifies that get API service request returns 200 OK with when authenticated. This verifies that get API service request returns 401 with a token, proving that JWT protection is working on service request endpoints. This verifies that get API service request returns a valid JSON array. This currency test verifies that get API currency rate returns 200 OK with the rate value. The MVC front end uses this to display the live USD to ZAR exchange rate. This verifies that get API currency convert returns a ZAR amount for the given USD amount. This client test verifies that get API client returns 200 OK when authenticated. This test verifies that get API client returns a valid JSON array. This verifies that get API client's ID returns 200 OK for a valid client ID. This verifies that get API client's ID returns 404 not found for a non-existent ID. This is the client endpoint test. It's a helper to get client JWT for testing. This method verifies that get API contracts my returns 200 OK when logged in as a client. Returns only the logged in client's contract. This verifies that get API contracts my returns 403 forbidden when logged in as admin. This is restricted to the client role only. This verifies that get API service request my returns 200 OK when logged in as a client and returns only the service request for the logged in client. This verifies that get API service request my returns 403 forbidden when logged in as an admin. This verifies that get API contracts client ID returns 200 OK for a valid client ID. This verifies that get API service request client ID returns 200 OK for a valid service client. This verifies that get API service request rate returns 200 OK with a rate value. This verifies that post API service request my creates service request for the logged in client. This verifies that post API service request my returns 403 when contract does not belong to the client. This verifies the delete API service request my ID returns 403 when service request does not belong to the client. These tests automatically run on every push on GitHub. The integration test can run locally before deployment. If any endpoints break, the test catches it before the code reaches production. Automated test creates a safety net that prevents breaking changes from reaching end users. In this section, I'll explain the three Docker configuration files: dockerfile.api, dockerfile.web, and dockerexpose.yml. Docker works on my machine problem. Docker packages the application, its runtime, its dependencies, and its configuration all together in a container. This container runs identically on any machine that has Docker installed. The container is completely self-contained. Docker API is a file. Dockerfile.api is this file tells Docker how to build the web API container. It builds two separate stages. The first stage is called the build stage. It uses the full .NET SDK image, including the compiler, build tools, and everything needed to compile and publish the application. Project files are copied before source code as a layer caching optimization. Docker caches each step as a layer. If the source code changes, but the project files and NuGet packages haven't, Docker reuses the cached restored layer and skips re-downloading all the packages. This makes the build faster. After restoring packages, it copies all the source files and publishes the application in release mode, which applies compiler optimization and removes debug symbols, making it faster and smaller. The second stage is the final stage. It uses only the lightweight ASP.NET runtime image. It only has what is needed to run the application. The final image is much smaller and more secure because it contains no build tools. Dockerfile.web follows the exact same build stage as Dockerfile.api. The first stage compiles and publishes the MVC project using full SDK. The second stage copies only the published output into lightweight runtime. Docker compose.yml. This is the file that starts all three containers together with a single command. Without this file, the containers would need to start manually, and the network would need to be configured by myself. This file automates the process. It defines three services. Container 1 is SQL Server Database, which runs SQL Server 2022. Container 2 is the GLMS backend API, which is built from Dockerfile.api. Container 3 is GLMS frontend web, which is built from Dockerfile.web. At the bottom, the GLMS network is defined as a bridge network. All three containers are on this network and can communicate with each other using their container names. Docker compose.yml orchestrates the entire application ecosystem. One command starts three containers, creates the network between them, and sets all environment attributes and ensures that they start in the correct order. The next section shows the containerization solution running in Docker desktop. And the three containers communicating with each other. You can see that all three containers are running. All three containers have a green status showing that they are running. This is the complete technique GMLS application ecosystem running on the Docker application, running in Docker containers. When I ran the Docker compose YML, Docker read that it started the containers in the correct order. First, SQL Server, and Docker began checking every 6 seconds if SQL Server was ready. Once SQL Server passed the health check, GLMS backend started. The API connected to the database and automatically ran the entity framework migrations. This created the technical logistics database and created the tables. Then GLMS frontend web started and connected to the API. The entire setup happened automatically. All three containers are on the GLMS network bridge network. They communicate using their container names as host names. The containers are isolated from each other. The file systems can communicate over this network through the defined ports.